correct? Okay, the problems we're going to deal with today are right here in the 5C.0507, correct? So we're going to solve these integrals. Okay, these integrals, right, are going to come from the fact that we are going to do the fundamental theorem for the derivatives of the inverse trigonometric. So let me just show something here before we begin, just as introduction. So, okay, let me just share screen, these ones. So these are the integrals we're going to be solving today. So here, I'm going to show you how to get the formulas to solve these ones. So remember the definition, for instance, the derivative of the arc sine of x, right, is 1 over the square root of 1 minus x squared. So if we take the integral both sides, so integral ddx of the arc sine of x equals the integral 1 square root of 1 minus x squared dx, these two cancel out, and then we find that the integral of this inverse of the radical function, this one, is going to be the arc sine of x plus a constant, correct? And all the other formulas are going to be the same, so you can see those formulas in your formula booklet. So right here, you see the formula booklet, right? You see here in this portion, the integrals, okay, well, right here. The integral of a squared minus u squared is our sine of u over a, assuming that now you have a number here different than 1. And, well, the other integrals were going to be pretty much obtained from the same formulas. Obviously, we are going to do only the positives, these 3 positive, not the negatives, because technically you get the same. So these are the formulas we're going to be using today, correct? So let's go to the first, I'll share screen, let me see this one. First problem. We're going to solve the integral of dx over a square root of 9 minus x squared, correct? So we're going to solve this integral. Okay, what is the integral we have to match? Okay, you have integral du over a square root of a squared minus u squared equals the arc sine of u over a, correct? So this is the trick always in integration. You have to go and look for the formula that pretty much looks like your integral. So it's okay, let me see. I have here the root in the denominator, then I have a minus. This is the difference of 2 squares, you see, a squared minus u squared. So here I don't have a square, but I can use my algebra, correct? So I can write this integral as the square root of 3 squared minus x squared. So here is my algebraic change. So I have a 9. Well, 9 is 3 squared. Now I have this matching completely this. So here, my a is 3, my u is x, and the du is the derivative of this times dx. So with these changes, I'm matching perfectly this one, right? So you see that with this change, I match this one. So I can simply put here, okay, this integral is going to be the arc sine parentheses, the u, okay, x divided by 3, correct? Plus my constant. So what is the trick? Again, the trick in these integrals is manipulate your expression such that the expression match one of the formulas you have. Okay, so you have to identify term by term. That's all the trick. Now, what algebra you have to use? Well, that is going to be depending on the problem. Sometimes the algebra is something as simple as this. Sometimes it's going to be a little bit more complex. Okay, questions here? Okay, so let me just go to the next one, right? So let me just go here. And then you have, for instance, the integral, you see B, integral dx over 5 plus x squared. Okay, so let's see which one of my integrals is going to fit that one. So, okay, can you see these little formulas, right? I'm going to stop changing the screen. So you have the reciprocal of something plus x squared. So I look, okay, I have a root. No, this doesn't work. I have a root here. No, this is the one that looks fine, correct? So I'm going to write the formula. So it's integral du over a squared minus u, no, plus u squared, the u is already there. So that's the integral, and this is equal 1 over a, the r tangent of u over a. So that's the formula I'm going to use, correct? Now, if I match this integral with this one, I know the answer. So, okay, let's see. This is the plus, so they look very fine, right? Look very fine. X with u, and then 5 equals a squared. Well, 5 is not a perfect square, but there is always a trick to do. So you have a equals the square root of 5 squared, correct? The square root of 5 squared is 5. Then the u is x, and obviously du equals dx, or 1 dx, if you want to see that. 1 times dx, correct? That is right there. So the only I have to do is write my integral. So I'm going to write my integral properly. So this is integral of dx over the square root of 5 squared plus x squared. And because this is matching, well, the only I have to do is, my calculus is 1 over the square root of 5, because that's a, the r tangent of x over a square root of 5. Correct? And obviously, plus my constant, correct? There's always a constant playing over there. Okay? So, not a big deal. If you have, this is the first trick you have to learn. If your number is not a perfect square, a number is always the square of its square root. It's a very simple trick. Okay, let's see another problem. Let's just go here. So we have now, let's see these two. These two are fine. So let's begin with the integral. The integral of dx over x square root of x squared minus pi. Okay. So this is now a radical, and it has a variable outside. So let me see my formulas. Okay. You can see this one. You see the three formulas we have to use. Okay. So we have u minus u squared minus a squared. 1 minus this one is the r secant of the absolute value of u over a. Okay, well, I'm going to use that integral. So it's integral of du over u square root of u squared minus a squared is 1 over a, the r secant absolute value of u over a, plus my constant, obviously, correct? Okay, now match 1 to 1. So again, it's easy to see that u is x, right? The a is this one, so it's a squared. So this is only pi, so I know the trick, the square root of pi squared. That's my change. And obviously the du is dx, correct? So I just change my variable here, integral du over x square root of x squared minus the square root of pi squared, right? And then I know the answer. The answer is going to be 1 over a. The a is this thing, so really this is square root of pi, right? This is square root of pi. The r secant of a square root, absolute value of x over a square root of pi plus the constant, correct? So you see, this is all the situation with integration. You have formulas like this. You have problems like these ones here. You have to match one to one, identify what you have, and then use the key to solve the problem. Okay? Okie dokie. So another one that is a little bit more difficult. You see this one D. So problem D. So in this case, you have the exponential. Don't worry, don't panic. Yes, everything is going to be worked out in the same way. 4 plus e to the 2x dx. Okay? Okay, now again, my formulas. My formulas, right here. So I have these three. So, well, it seems that just the mid one is going to help me because this has a radical, this has a radical, so there is no radical here. So let's see this mid one. So I'm going to write my formula. So it's integral of du over a squared plus u squared equals 1 over a, the arctangent of u over a, plus my constant, correct? Plus my constant. Okay. Well, let's see. How can we match this one? Let's see. Okay. This is a plus, so it seems that I'm going to match these two. So 4 is a, the square. So that's not a problem. So a equals 2, right? A equals 2 because, well, 2 squared is 4. Then the u has to be u squared is e to the 2x, correct? So a squared is a square root of 2 squared. Let's just do like that now. And then I have to remember this. E to the 2x is e to the x squared. Why? Because algebra 1, again, so a to the n m is a to the n to the m, correcto? Right? So I'm doing exactly this trick. So this is, well, the u is e to the x, right? Then du is derivative of e to the x, that's easy, e to the x dx. So these are my changes. So if you see this integral right here, this is okay. Du is right here, so I have to put this together. Then this is a square, and this is another square. So I'm going to write my integral in the proper way. So it's integral of ex dx over 2 squared plus e to the x squared, right? Now, this is going to be, obviously, integral of du, all this is du, This is going to be 2 squared plus u squared. And this is going to be simply this formula. So I'm going to put right here is 1 over 2, the a is 2, the r tangent of u, well, u over 2 plus c. And then the last thing I have to do is, okay, who's the u? Well, the u is e to the x. So I'm just going to write my formula, 1/2 the arctangent of e to the x over 2 plus c. Okay. As you notice, this is, again, the u substitution we did some classes ago. Nothing different. U substitution is the way to proceed with integrals. And the U substitution comes when you compare the problem you get with the formula you may use. Correct? So remember, here is your algebra. A little algebraic trick. Remember, this equals this. Then you can use the formula. So it's basic algebra again. Any question here? No? Fine? Okay. Let's move to the next page. So in the next page, we have pretty much the same kind of problems, right? Yeah. So for instance, this one, I'm not going to do this problem because pretty much repeat the same thing, right? Yeah. But I'm going to do only the trick. So I have the integral, the integral of dx over square root of 9 minus 4x squared, right? So again, let me just go back to the screen. You have this integral. So what you're going to do simply is you're going to write this one. So you're going to put dx, and then you remember that these are difference of squares. So this is going to be the square root of 3 squared minus 2x squared. Once you have your expression written as the difference of 2 squares, yep, then what formula you're going to use? Well, this one right here, you see? The arcsine of u. So it's very simple. So you have to put here the u, the a, and this is the solution. For the other equation, other problem, and this one right here. So you have integral dx. This is the integral of dx over x square root of 5x squared minus 3. Okay? Again, your formula, right? This is okay. Which one of the formulas is going to fit this one? So, okay, I have here my formulas. Is the last one. So I need a u outside, then the difference of 2 squares again. Okay, not a big deal. These numbers are not perfect squares, but I can manipulate them. So this is going to be integral, right? Dx over x, the square root of, okay, a square root of 5x, everything is square. Now see, the square root of 5 squared is 5, x squared is here, minus the square root of 3 squared. There is always a square over there when you need it, correct? If you remember the trick, square root square is the number. Yep. With this one, okay, you can apply your formula directly, problem solved. So let's see another one, pretty much. The next one is going to be the same. Okay, let's see this one. These two. These two are going to require something, right? The next one is integral, right, of x plus 9, integral of x plus 9 over x squared plus 9, correct? Dx. Let me just close that here. So this is my integral. Okay. Now, if you see your formulas, it's okay, let me see. again, I have x squared and 9 is 3 squared. So I have x squared plus 3 squared, or 3 squared plus x squared. Then I see, okay, this is the denominator. But I have at the top something that is not what I have here. I have an x plus 9. The 9 is not a problem because I put a 9 and I remove the 9. 1 over 9 times 9, that's fine. But I have the x. So I have to do something. I says, well, this is the trick to open this problem. It's okay. So you remember your algebra 1 again. So you have that a plus b over c is a over c plus b over c, correct? Common denominator, fractions. So x plus 9 over x squared plus 9, right? X squared plus 9 is going to be x over x plus 9 plus 9 over x squared plus 9. Okay, now this is a square, correct? So this one, if you integrate this portion, is going to look as your formula, you see? And this one, well, is going to require possibly the use of another formula, correct? The other fraction you have, remember, is your natural log that is here at the top, correct? So let me just write my integral as I did it right here, correct? So this is going to be the integral of x over x squared plus 9 dx plus the integral of 9 over x squared plus 9 dx. Okay? So using my algebra, I split these two, correct? Okay, now let's see my first formula. So I have the integral of du over a squared plus u squared is 1 over a, the arctangent of u over a plus c, correct? This is my first formula. What is the other formula? This is going to be for this one. The 9 can be moved out, so the 9 is not a problem. Constants are never a problem. So this is going to solve this one. But what about this one? Well, this is a fraction. What is the other integral for a fraction? Is this one. Integral du over u equals ln absolute value of u plus c. This is the only other fraction you have, and we have used this before. So let's see. If the u is x squared plus 9, what is the derivative of x squared plus 9? 2x. Okay, I have x. If I need a 2, I just put a 2 and I divide by 1/2 or multiply times 1/2. And that's not a problem. So I'm going to do 2 u substitutions, correct? So the first one, right? Let me just use a different variable. Let me just use a v, and use a v, correct? So in this case, for this first integral, the a is going to be 3 because a squared is 9 or 3 squared, and the u is going to be the x. So the dx or the du is going to be dx, correct? Now, what happened in this case? Well, I'm going to have here the v. Okay, the v is x squared plus 9, and then dv is going to be 2x dx. Only this because the derivative of the 9 is 0, so it's just 2x dx. So I see what I need. You see here. For this one, I need a 2. X dx is right there. X squared plus 9 is over there. So this needs half and 2. And here, you only need to push this out from the integral. So I'm going to do that. So this is equals the integral. Okay, 2x dx over x squared plus 9, and then I put here my 1/2 to balance these two, plus 9 integral dx over x squared plus 9, correct? Now I'm going to change my integrals. So this is going to be 1/2 integral dv over v. You see? dv over v. This, I use this substitution, plus 9 integral du over, in this case is, let me just put this line, is going to be 3 squared minus u squared. du. Okay, now solutions for these integrals is okay. This is 1/2 ln, so ln of absolute value of v, plus 9 is going to be times, okay, is 1 over a. Well, a is 3, so it's going to be 1/3 the r tangent of u over 3, correct? U over 3. Same formula, correct? Plus my constant, okay? Now, well, I'm not going to fit right here, so I'm going to move to the right a little bit. So this is going to be equals, I use the substitution, so it's 1/2 the ln of v. Whose was v? X squared plus 9, so absolute value of x squared plus 9, plus 1/3 and 9, this is 3, the r tangent, u is x in this case, so I'm going to put x over 3 plus the constant. So here is my answer. Okay, so what was the trick here? Okay, the trick was the integral was split in two integrals. Okay, go back to the board. So this fraction was broken in two fractions. Another trick you have to learn. So one integral that is not possible to solve is broken in two integrals that you can solve. And here is the procedure. Everyone has a formula, so you make the proper substitutions for the formula, and then you get the answer, correct? So it's very systematic. You look for what you can use. Remember, screen, let me just check this one right here. So, yeah. Okay, let me just open again this thing right here. Okay. Can you see the formula chart? Okay, here is. So these are the integrals we have. So we have to make reference or see these formulas, correct, to solve the problems we receive. Right now we're focused on these three, but you may have other fractions that have to be solved with the natural log. Obviously you have a sine or a cosine or secant, square. Well, you solve these ones, right? You use these ones. Okay, exponentials. So now your spectrum of formulas is complete. So you have to look from all these formulas, which one match your problem you have. And remember the tricks to make them match. Okay, now I'm going to do the last trick. Let me see right here. Right here again. So this one, correct? Okay. Before move, problem H. What is the change you may do? This is x to the 6, right? You see, x to the 6. So the integral x squared over square root of 1 minus x to the 6 dx. Let me just stop sharing this integral. Remember that you need difference of squares. So integral x squared over a square root of 1 square, well, 1 is 1 square, minus, okay, x to the 6 is x cubed squared. Now, what is the derivative of x cubed? 3x squared. Here is the x squared, correct? So the only you need is a 3 that you can put and take, and then you solve the integral. You see? Algebra again in action. Okay, let me just now go and look for something more. Here you see this one, right? Yeah. I, for instance, let me just show I, is dx over the square root of x, 1 plus x, yeah? And for instance here, yeah, this is going to give you a little bit trouble, right? Because the formulas, let me just show you here, the formula is right here, is a variable outside this one. So here the problem is quite simple, that you have the plus in the wrong position, correct? Yeah. So in this case, what you can do is, okay, let me see. Let me just use a variable, I don't know, b. b equals x plus 1. Then x is v minus 1, correct? So dv equals dx. So no problem with this one. So you change the integral as the integral at dv over is v, this is x, is v minus 1. So you have a square root of v minus 1. And then when you multiply x plus 1 from this one, x plus 1 is v, correct? You have negative 1, you add, x plus 1 is v, so you have v, correct? So you see, now, this formula looks more than this one, correct? A little bit more, correct? So that's the way we can proceed in this case. So let me just go a little bit more ahead. And well, you have here the same. This is 1 squared minus 2x squared. And this one, this is the one I wanted. So you have the integral 3dx over x squared plus 6x plus 18, correct? So that's my integral. Okay, now I check my formulas. Okay, let's see all the spectrum here. Yep. Okay, this is a fraction. So let's see the first possibility for a fraction. This one, the natural log. Okay, if you take all this as u, as the formula says, the du is 2x plus 6 and dx, correct? So you don't have an x here at the top. So this formula cannot be used. Obviously, you cannot break this fraction, correct? No way. Let's see the other ones. Okay, the other fractions are these three. Here you have a square root. There is no square root here, so you cannot use that. Here is another square root. No way. The only one with no square root is this one, u squared plus a squared, correct? So it seems that is the only possibility because you have here du and you have here dx. The 3 can move out, can be moved out, so no problem. So let's see if we can match that integral. So integral of du over a squared, or is a squared plus u squared, yeah, or u squared plus a squared. Let me just put it like that. U squared plus a squared, and that is 1 over a arctangent of u over a, correct? Plus the constant. Well, let's see. Okay. Here I need u squared plus a squared. So I have to write this as the addition of two squares. So this is, well, looks weird because I cannot factor this thing directly, correct? This is, no, it's not possible to factor, but I have to remember the completing the square. What happened in the completing the square? Let me just show you. X squared plus 6x plus 18. So you cannot factor this to solve, but you can group these two and then add a number such that it matches a perfect square. Remember, what is a perfect square? A plus b squared equals a squared 2ab plus b squared. That's a perfect square, correct? A plus b squared. You have to remember this formula. This is a pretty much advanced formula for algebra 1. Okay, now let me just match. X is the a square. Then here is the a. Then this one, yeah, has to be the 6. You see, 2b has to be the 6, correct? So how can you break the 6 to match this one? This is okay. Let me just break my fraction. My product is x squared. I don't change that. Then 2 times 3 times x, correct? Plus 18. And I'm going to put here a space because I need b squared. So let's see now. Okay, now again, a squared is x squared. 2 is 2. A is x. So who has to be the b? No way out. B has to be the 3. Now, the formula asks me for a b squared. So, if b is 3, b squared is 9, correct? B squared is 9. And if I put a 9, I have to remove the 9 also, correct? Because I have to keep the same expression. 9 minus 9 is 0. I have the 18. I have exactly the same expression. Now, this is the point. I can group this one as this. So, x plus 3 squared, because the b is 3. So this is x plus 3 squared plus 18 minus 9. That's a 9. And obviously, I have here x plus 3 squared plus 3 squared. So now you saw that you match this denominator with the addition of 2 squares, correct? So my solution is going to be very simple. Once I did all this, my u, my a is 3, my u is x plus 3, and the du is the derivative of this, that is a 1 times dx. So I know the answer, right? So the integral, right? The integral of du over x plus 3 squared plus 3 squared is going to be, well, if I do these matchings with this formula, right? I'm going to put here 1 over a, the a is 3, the r tangent of the u is x plus 3, you see here. So it's x plus 3 over 3 plus my constant. So you see the change to match this integral? Again, algebra. If this is not done, this integral cannot be changed into something with solution, right? So this is the last trick I wanted to show today. Okie dokie. Questions before move to the last example? Let me just look for another one in the practice. So what part is not clear? Remember, this is in my formula chart. When I receive a problem, I try to find something matching. This is, well, the most similar is this one, not the same. So how can I manipulate my expression to match this one? Here is the trick, completing the square. Once you complete the square, you identify the terms in your formula and you solve. So remember the completing the square? Yeah? Yvonne, you remember completing the square?
Más o menos.
Bueno, ahora sí tienes que hacerlo más. ¿Ok? ¿Ok, Luis?
Ajá, sí está bien.
Okay, well, let me just check if I have an extra example here. Yeah, let me see. Okay, let me just use one of the last ones with definite integrals, right? In case give you trouble. Let me just use this one. This is going to be a good one. In that way, I put the definite integral example and finish today. So I have the integral from 1 to 3 of dx over x squared minus 2x plus 5, correct? So I have my integral. There it is over there. Okay, now again, look in my formula chart. Okay, this is a quotient, so again, I look at first quotient I have, du over u. So if I take all this as a u, the derivative is 2x. I don't have an x here, so this is not the formula. Okay, go back to the last one. Okay, there is no way out. Has to be this one possibly, because I have radicals here. I have no radicals in the denominator, so I'm going to try to match this again. So I'm going to match integral du over u squared plus a squared equals my arctangent. Correct? Okay, let's see. Now, this is the addition of two squares. I have to make this the addition of two squares. So, well, the only way I can do that is try to find this as a perfect square. So I have to complete the square. So I'm going to do my algebra. X squared minus 2x plus 5. Okay, so let me just put this a little bit right. So x squared minus 2x plus 5. And, well, I'm going to do my formula. So, this is different color. This is a plus b squared equals a squared plus 2ab plus b squared. Remember this formula I'm given by default that you know it, okay? So, just write this plus 5. Okay, now I have to match this one, so x squared is the a, so that's always the same. So I have x squared, then I need a 2. Well, here is a 2. So minus, well, remember this is also with a minus. Let me just put here the minus, right? And this is negative 2 times x times 1. I need a number. Well, 2 times 1 is 2. Okay, now let's match. A is the x, A is the x, 2 is the 2, so the b has to be the 1. So I'm going to put plus 1 squared plus the 5. This 5 is right here. I repeat the 5. And because I put a 1 squared, I subtract the 1 squared. Well, 1 squared is 1. Let me just put it right there. Okay? So this is going to be written like this. So this is equals x minus 1 squared plus 5 minus 1, 4. And obviously, this is x minus 1 squared, right? Plus 2 squared. Okay? So you see, now this is the addition of two squares as my formula requires. So I'm going to do my change. So my change is u equals x minus 1. X minus 1. Du is dx. Derivative of x1, derivative of 1, 0. So it's dx only, 1 dx. And then, well, my a is 2, correct? So my change is going to be simple. So this is going to be integral of, let me just write it in the color of the original. So is the integral from du, in this case, du is dx, well, dx, let me just put it right here, dx over x minus 1 squared minus 2 squared. But here I'm going to change to u. So this is going to be integral du is dx, over u squared minus 2 squared. But here is a problem. What is the problem? 1 and 3 are values of x. 1 to 3. I cannot transfer the 1 and 3 here because this is an x and this is a u, and they are not necessarily equal. So what is the trick? I have to change the limits of integration. So for x equals 3, the u is 3 minus 1 because u is x minus 1. So it's 3 minus 1. So u is 2. When the x is 0, when the x is 1, when the x is 1, here in the limit of integration, right? U is 1 minus 1 because u is x minus 1. So this is 0. So these are the changes. When the x is 3, the u is 2. When the x is 1, the u is 0. So it's what I have to write right here. So let me just put in the color. So it's integral from 0 to 2 du u squared plus 2 squared. Correct? Now, the solution is right here. So I have just to put my solution. This is going to be 1/2 the arctangent, right, of u over 2. But what is the difference? Now you have to evaluate this function from 0 to 2. You don't have to add a constant. So now you have, because this is a definite integral, remember the fundamental theorem. You have to evaluate the antiderivative in the limits of integration. And here is going to be the difficult because you have to do, okay, 1/2, this is not, this is 1/2 the arctangent of 2 over 2. 2 over 2 minus 1/2 the arctangent of 0 over 2. Now we have to remember our precalculus. 1/2 the arctangent of 1 minus 1/2 the arctangent of 0. Okay, what angle, the tangent of what angle is 1? Remember? No? Okay. Here is lifesaver. Go to the unit circle. Here is a table, right? Here you need arctangent of 1. So for what angle tangent is 1? You see here, pi over 4. For what angle tangent is 0? For 0, right? So this is 1/2 pi over 4 minus 0. And 1/2 of pi over 4 is pi over 8. Okay, pretty much it's clear what to do. Yes, integration is a long process. Check this out. Many changes, many little things to consider. Check the green ones, the orange, algebra. Then the trick, then remember that you have to, when you do a u substitution, you have to change the limits of integration. If you do from 1 to 3, you mess up completely, correct? So the u goes from 0 to 2, then you evaluate, and then you have to remember your precalculus, this, okay? The values of the function. Questions here? Boring class? Yes, I know. Well, nobody's here. Nobody was here. Just you three. Okay,